we will use logarithmic differentiation and implicit differentiation to come up with formulas for the derivative of e to the x and a to the x. Let's start by taking natural log of each side. Natural log of y equals natural log of e to the x. And we take natural log so we can apply the power rule here. The power rule allows you to bring the power down in front of the log, multiplying it by natural log of e. And we know natural log of e is equal to 1. So far we have natural log of y is equal to x times 1, which is equal to x. Okay, next we'll do the derivative with respect to x. The derivative of natural log of y is 1 over y multiplied by the derivative of y, dy dx. That is our chain rule right there, because y is some type of function of x. And on the right-hand side, derivative of x is equal to 1. So let's isolate dy dx. We can do that by multiplying y on the right-hand side. Y times 1 is y. And then we'll do a substitution step. Y being e to the x. So what we have here is that the derivative, dy, with respect to x, is equal to y, but we're substituting e to the x in its place. So what this means here is we have the derivative with respect to x of the function we started with, e to the x. It is in fact equal to e to the x itself. Let's apply the same thing to a to the x. We'll start by taking natural log of each side. Natural log of y is equal to natural log of a to the x. Apply the power rule, bring the power down in front of the log, multiplying by natural log of the base a, and then the derivative step. Derivative of natural log of y is 1 over y multiplied by chain rule dy dx equals natural log of a times x. What that is just a constant multiplied by x. Let me recap something real quick here. If you take the derivative with respect to x of some constant multiplied by x, it's just equal to that constant. So now we have some constant natural log of a multiplied by x. The derivative of natural log of a multiplied by x is just natural log of a, whatever that constant was. And let's isolate dy dx. We can multiply y to the right-hand side. Y multiplied by natural log of a. And then the substitution step again. Let's substitute y. So we have dy dx equals y being substituted with a to the x being multiplied by natural log of a. And this establishes for us a formula where the derivative with respect to x of a to the x is equal to a to the x multiplied by natural log of a, natural log of whatever that base is. Now it's also nice to see that this formula applies to e to the x as well. The derivative with respect to x of e to the x, if we use this formula and write it as e to the x multiplied by natural log of e, we know natural log of e is equal to 1. So that still gives us the derivative of e to the x being e to the x. So it's nice to know that e to the x is just a special case of this formula for the derivative with respect to x of a to the x.